Okay, so for this worksheet that we have now in front of us, it's an extension of the practice on combining functions. Combining functions. And how did we combine the functions? We have so far combined the functions by adding those things. So I have highlighted here f plus g. F is a function. What is the function f? This green highlighted is the function f. And then we have the function g also, which is yellow highlighted over here. So whenever you will have an addition f plus g, what you're supposed to do, you will add the given function. Here in the A part of question number 1, we are supposed to take the function f, take the function g, and then add those together. Okay, let's do that quickly. It's easy thing. F of x, or the f, is a negative 2x plus 6. We just have written this function over here. And then after that, I will put the addition. Why am I putting an add sign here? Because the blue circle add, addition, is telling me I need to add these functions. Okay? Then I will bring in the other function, which is a 5x minus 7. 5x minus 7. That's how we will do it. Let me bring it a little bit closer for the better view. Now we are fine. So I need to take the function, add it, and then comment on its domain also. When I will put here the addition, let's remove the parentheses. Negative 2x plus 6 plus 5x minus 7, adding the terms alike. Look at this. This yellow highlighted set of terms, two terms, are including x. So I will bring in these two together and write those down as 7x. And the one which are not highlighted, 6 and a negative 7, are alike. So we will add those two together, but because of the sign, that will be a negative 1. That will be a negative 1. Make sense? So negative 7x minus 1 is the function. Now, how can I find out its domain? We need to find x. What values can x variable assume here without getting undefined? For this simple function, it's like a straight line. So there is no restriction. There is no hold on this. You will simply mention the domain, all real numbers. So domain will be all real numbers. You can write it like that simply. And R, you can do it in another manner also. X belongs to the real numbers. This E looking thing, let me bring it back again. I think it's taking a little bit time to appear on the screen, but once you will see, it should be clear. X belongs to R. I'm intentionally putting this additional line next to R because that is differentiating the real numbers from a simple R. So X belongs to R is one way of writing the domain. Another way of writing the domain, I can use the curly brackets. And with the curly brackets, what I will claim X such that X belongs to R. I can do the same thing using these curly brackets also. Both are fine for me. Make sense? So we said domain is all real numbers. How did I get the 7? My bad. You're right. Negative 2 plus 5x. In fact, it's a change, different signs. So we will subtract it. Thanks for mentioning that, Ramiro. We have negative 2x plus 5x. It will actually be subtracted. So 5x minus 2x, what should that be equal to? 3x. Negative or positive? That should be a positive 3x. Good that we have correction also in the recording. Okay, so I'll not have to record it again. avoid the typos. Cross-checking will always be helpful. So positive 3x minus 1 is going to be the function for which we have just mentioned the domain x belongs to the real numbers. Now, do we really need to find it out? You know, there is an easy way of writing the domain for the composite or the combined functions as well. And what is that easy way? Can you tell me what should be the domain for f of x? Is there any hold, any restriction on the variable x? What kind of a hold be there? Let's say, I'm just giving you an example. You don't need to note it down. If I have a function which is 1 over x, in this case, 1 over x, x should never be equal to 0. And if I will be writing the, don't write it down. You don't need to write down the blue thing. Just listen to what I'm saying. In this case, domain cannot assume or take the number 0. So in this case, the domain will be all real numbers, but 0. 0 is not there. But in case if x is simply like a straight line over here, and the domain is all real numbers. For this also, the domain is all real number. So for simple addition and subtraction, or even multiplication, normally the domain will not change. You can mention here also, domain is all real numbers. So what I can see, I can claim all real numbers will be the domain for the second function also. All real numbers is the domain. Make sense? Easy thing. As far as these are the last thing is an R over here. Just corrected all real numbers. Thank you. Make sense? Domain in these cases is all real numbers. Then we have one of the, for question number 2, let's think about that. For question number 2, f of x is 5x squared minus 4x. If you're still taking notes, I will wait for you for a while. And for that wait, what I will do, let's stop the video.